Okay, here is a two-sample t-test for comparing population means from two separate populations. Here we have another medical scenario where we're looking at surgical procedures. It's kind of, if you looked at my intro video, I talked a little bit about this. And we're looking at an orthopedic doctor looking at two different ways of improving or comparing two different procedures to see if one was better, the new one's better than the old one, or the standard, I should say. And this is kind of like a basic standard in the medical, community that, if they come up with something new, they'll compare it with something that's been, proven and used over a period of time. They say that they select these, people randomly for these procedures, but what probably happens is they volunteer to go in the study, and then they have to agree that they're going to let chance determine which procedure they're going to get. So that's part of volunteering being in the study, and so that would be randomly assigning them a treatment, so to speak. But here they're just putting it in terms that they're sampling from populations, which the randomization in the experiment again is equivalent to that. So anyway, they give us the summary statistics. In this case, they don't just give us the data for the 11 and 10 patients. So the 11 have the new procedure and the 10 have the standard. And so basically you just need to type these numbers in here, 363.2 and the 381.5, okay? Sample sizes of 11 and 10 right here. The standard deviations, you got to do a little bit of work for that because you just got to be careful here. Don't type these numbers in because this is the variance. So I'd have to use the calculator here to find the square root of these numbers here. So the first one here, if I take the square root of 2515.4, I'm going to get about 50.154. I probably did some rounding there when I did that. And I kind of had a lot of this stuff entered so you don't have to watch me scrambling around typing it. It's just going to make the video longer. And of course, pause this if you need to, just to kind of catch your breath. And, you can obviously scroll to, back and forth as necessary. But anyway, this standard deviation comes from just taking the square root of the sample variance here. So again, using the calculator, take the square root of this number and you're going to get to 19.98. With that said, all you really need to do here is, kind of set the rest of this stuff up. This gives me my p-value and my t-statistic. Again, so, where's all this stuff come from? Again, we could have entered in mu1 equals mu2. Sometimes, like I said, some people prefer this method. Mu1 equals mu2 is the same as mu1 minus mu2 equals 0. All right, right? If they're the same, subtract them, you're always going to get a difference of 0. And here we're looking at mu1 being less than mu2 because here we're looking at mean recovery time, right? So the new procedure, if it's better, the mean recovery time is going to be less than that. So, again, a lot of times it's easier to type in mu1 less than mu2. That would, be a way of deciphering that. But this one, again, I just hit the solve feature here. So I was being lazy, so I didn't have to type the stuff in. But so anyway, that's you could enter it either way, mu1 less than mu2 or mu1 minus mu2 less than 0. All right. Degrees of freedom, if you remember, you take the two sample sizes, pick the smaller of the two, subtract 1 to get the degrees of freedom. It also does that for you over here if you forget that. So you just have to look at the right spot here. All right. As far as the test statistic, again, all I have to do is look over here for my t statistic. So here it is, negative 1.117 rounded to 3 decimal places. And again, they don't want the p-value for this one, but if they did, you would do the p-value for the left test, which would be about 0.1465. Okay, so right there, looking at the p-value here, there's not enough evidence because the p-value is greater than that, right? If it was less than that, we would reject the null and we would say there is enough evidence. But since that's not the case, right, we got a p-value here greater than that, we would select no. But for this problem here, again, they're asking you to use the critical value method. So if it did call for the p-value, all you would do is just look over here and my conclusion would be the same, which would be no. However, if I'm used the critical value method, it's like, well, where do I find this? Okay. And I think the easiest way to do that is to, again, just not search on your template, but just come right over here and use the calculator with the T. And if we want 5% in the left tail, we would select this with 0.95 in the right tail, okay, with 9 degrees of freedom, and just hit equals or enter, and there's my negative 1.833. Okay, so that's probably the easiest way of getting that is just off of your ALEKS calculator. So now, using that method here, again, I could double check it. You know, I could really type that in there, and I've already answered that question. But if I was using this method here, again, this value is right. If I had like that bell-shaped curve here, and I had this value plotted at negative 1.8, well, the area to the left of that would be 0.05. Well, this is to the right of that. So on that bell curve, this would be to the right of that. So the area to the left of this statistic right here would be more than that. And that would tell me that my p-value would be more than 0.05. And so again, I would select no. Again, that's using the critical value method. All right. They both lead you to the same conclusion. This one tells me my p-value is more than 0.05. If I just use the p-value method, I look and I say, yeah, 0.14 is greater than 0.05. All right. So although the critical value method, again, does not give me what the p-value is, it tells me what it is relative to the alpha. All right. So there you have it. You know, pretty straightforward. Again, we're just typing some numbers in. We just have to know where to look over here to get the output that's required to put into the appropriate spots to answer the question. All right, so there you have your, again, a hypothesis test for the difference of population means. We use the t-test because, again, we do not know what the population standard deviations are. If we did, we would use the z-test, which, again, is in the other video. So, all right. So, again, trying to keep these short. So I'll wrap this one up and hope this helped.